The cosmic mystery. Where did Earth get its water? The journey to uncover the origins of water on our planet is one of the most compelling quests in science. Earth is a remarkable anomaly. It is the only known world in our solar system with vast, stable bodies of liquid water on its surface. This water, which covers 71% of our planet, is the cornerstone of life as we know it. But how did it get here? This question remains one of science's greatest unsolved mysteries. Two new scientific studies have brought researchers closer than ever to an answer. Water on Earth. The numbers. To understand the mystery, one must first grasp the scale and distribution of Earth's water. A water molecule itself is a simple structure, one oxygen atom and two hydrogen atoms. Total volume, there are approximately 12.34 trillion liters of water on Earth. Oceans. A staggering 96.5% of all Earth's water is saline and found in the oceans. Atmosphere. A tiny fraction, 0.001%, exists in the atmosphere. Freshwater. Only 3.5% of Earth's water is freshwater, locked in ice. Of that freshwater, 68.7% is locked away in glaciers and ice caps. Usable water. Ultimately, living organisms can only utilize about 1% of the planet's total water. These statistics are well known, but they highlight the central puzzle. Why us? No other planet in our solar system is known to have stable liquid water on its surface. The snowline problem. The why is so difficult to answer because of where Earth formed. To understand this, you need to know about the snowline. The solar system's snowline is the distance from the Sun beyond which water could condense into ice during the system's formation. This line originally fell between the orbits of Mars and Jupiter. Planets forming inside this line, like Earth, should have been too hot for water, which would have existed only as vapor. Planets forming outside this line could accumulate water ice. It is surprising that Earth has so much water as it formed in the inner solar system, likely inside the snowline. Explains Megan Newcombe. Earth accreted in a region of the solar nebula that was close to the Sun, and therefore likely warm and relatively dry. The accumulation of water ice on the nascent Earth should have been limited. If our planet's proximity to the Sun left it parched, how and when did it acquire its vast water supply? Theory 1. Delivery from space. The meteorite debate. For years, scientists have proposed that Earth's water was delivered en masse from elsewhere in the solar system, but the exact source remains unproven. There is a lot of debate about the origin of Earth's water, Newcombe told All About Space. Some argue it came from comets, others from the hydrogen-rich solar nebula, and still others from asteroids from the inner or outer solar system. The strongest evidence has pointed toward asteroids. The isotopic composition of our water matches the water composition in meteorites, which are fragments of asteroids, Newcombe notes. This is evidence that asteroids could be the main source of Earth's water. However, there are many types of asteroids. The question is, which ones? New study, ruling out Achondrites. Newcombe recently led a study to test one theory, that melted meteorites, known as Achondrites, were the source. These rocky meteorites broke off from planetesimals and could theoretically have delivered water. Our study looked at the impact of thermal processing and melting on the water budget of asteroids, Newcombe said. We wanted to study a specific family of Achondrite meteorites that formed in the outer solar system, beyond the snowline. Her team analyzed 7 Achondrite meteorites that fell to Earth using a technique called secondary ion mass spectrometry, or SIM. This involved meticulously baking the samples in a high-vacuum oven to remove terrestrial surface water and then analyzing their chemical composition. The results were unequivocal. We found that the melted meteorites are very dry, Newcombe stated. The samples contained water at a concentration of less than 2 parts per million. This rules out their parent planetesimals as the origin of Earth's water. This discovery is crucial. It suggests that any water accreted by the proto-Earth was lost during its early, hot formation phase up until it reached about the size of Mars. Only after it grew larger could it retain water. By ruling out Achondrites, the study points to a more likely candidate: Carbonaceous Chondrites. These are unmelted meteorites that are incredibly water-rich, containing up to 20% water by weight, about 100,000 times more than the Achondrites. Our results suggest that unmelted material delivered water to Earth, Newcombe concludes. This material could have arrived late in Earth's formation, allowing it to be retained. Theory 2. Earth made its own water. While Newcombe's study refines the delivery model, another recent study proposes a radical alternative. Earth's water wasn't delivered, it was manufactured here. Anat Shah, a scientist at the Carnegie Institution, co-authored a new mathematical model, suggesting Earth's water source is much closer to home. Our motivation was to see what would happen to Earth's evolution if we treated it like an exoplanet, Shah told All About Space. Astronomers have noted that newly formed exoplanets are often surrounded by atmospheres rich in molecular hydrogen. The researchers wanted to apply this lesson from exoplanets back to our own world. They discovered that early interactions between Earth's magma ocean and its primitive hydrogen-rich atmosphere could have made it a water world. The model takes a molten Earth, surrounds it with hydrogen, and then lets all the chemical reactions play out, Shah explains. In this model, as the planet formed, chemical reactions between the hydrogen atmosphere and the oxides in the metal magma ocean produced vast quantities of water. A lot of water is created and goes into the mantle and atmosphere. The result is a lot of water, even if the rocky materials colliding to form Earth were all dry. This theory doesn't exclude water arriving via asteroids, but it suggests those external sources may have been far less important. Summary: the three leading theories. The intense scientific investigation into this mystery has produced three primary hypotheses for how water appeared on our planet. Theory 1. Asteroid delivery. Many scientists favor the hypothesis that water arrived via ice-rich asteroids during the late heavy bombardment period, around 3.9 billion years ago. By this time, Earth had cooled enough to retain the resulting liquid. Theory 2. It was here from the start. This argument posits that Earth accreted water-rich materials directly from the original nebula of gas and dust that formed our solar system. The planet would have locked in this water from the very beginning, allowing it to survive even at high temperatures. Theory 3. Earth made its own water. According to the new research from Carnegie and UCLA, Earth's water is a result of chemical interactions between the magma ocean and its primitive hydrogen-rich atmosphere. As hydrogen moved into the planet's metallic core, its oxidation created water. Water is the wellspring of life on our planet. Understanding its origin not only tells us about our own past, but also guides our search for life elsewhere. As Dr. Shah noted, if we find out where Earth got its water, perhaps we can figure out which other planets have water in liquid form. It could start to give us a path for finding life. The journey to solve this mystery continues. Based on this, which theory do you find most convincing?
Thanks for watching. Don't forget to like this video if you find it interesting, and subscribe to the channel to join our journey of exploring the universe.